くりレ夢ムです。
ゆっくりマリサだぜ。
Hi, Raimu Marissa. Hey guys. P400. The Boltzmann Brain. The terrifying mystery hiding inside physics.
ゆっくりしていってね。
Section 1. Hook, what if everything you remember, your entire life, every person you've ever loved, every place you've ever been, was created 5 seconds ago? Not as a memory of something real, as a false memory, a complete fiction, spontaneously assembled by random chance out of empty space. And what if you, the thing experiencing this right now, aren't a human being who grew up and had a childhood and watched this video? What if you're just a brain, a disembodied brain, floating alone in the void of deep space, existing for just a few seconds before dissolving back into nothing, with no idea that's what you are? This is not a horror movie concept. This is a legitimate scientific problem. It has a name. It's called the Boltzmann Brain, and it emerged, completely unexpectedly, from some of the most respected equations in modern physics. And the strangest part? Physicists still don't know how to rule it out. Section 2. The story begins to understand the Boltzmann brain. We need to start with a 19th century physicist named Ludwig Boltzmann. Boltzmann was born in Vienna in 1844. He was brilliant, passionate, and deeply troubled, a man who spent his career fighting for ideas that most of his colleagues refused to accept. His central contribution was to explain thermodynamics, the science of heat, energy, and disorder, using the behavior of atoms. At the time, atoms were not universally accepted. Many leading scientists believed atoms were just a convenient fiction. Boltzmann believed they were real, and that the laws of heat and energy could be explained by tracking the motion of enormous numbers of real atoms. He was right, but the scientific establishment resisted him for decades. And in the process of defending his atomic theory, Boltzmann made a series of arguments about probability and entropy, about how likely different arrangements of matter are, that would, more than a century later, accidentally create one of the most disturbing problems in modern cosmology. He died in 1906, tragically, by his own hand, while his ideas were still being debated. He never lived to see them accepted, but the problem he accidentally created, that one is very much alive. Section 3. The evidence. Let's go through the evidence. Because the Boltzmann brain problem doesn't come from one place. It builds up, layer by layer, from physics that is separately confirmed and separately solid. And when you put the layers together, you get something deeply strange. First piece of evidence. Entropy always increases. Boltzmann's greatest achievement was explaining the second law of thermodynamics in terms of atoms and probability. The second law says that in any closed system, entropy, roughly, disorder, always increases over time. Heat flows from hot to cold. Ordered things become disordered. A dropped glass shatters. A shattered glass does not spontaneously reassemble. Boltzmann explained why. Out of all the possible arrangements of atoms in a system, the overwhelming majority are disordered. When you let atoms move randomly, they almost always end up in a more disordered state. Not because disorder is forced on them, because there are vastly more disordered arrangements than ordered ones. An intact glass is one specific arrangement of trillions of atoms. A shattered glass is billions of possible arrangements, vastly more likely to appear by random shuffling. The early universe, right after the Big Bang, was in a state of extraordinarily low entropy. Everything was arranged in a very specific, very ordered way that allowed stars, galaxies, planets, and eventually life to form over billions of years. But here's the problem. In a universe governed by probability, a low-entropy starting state is extremely unlikely. An extremely disordered starting state is far more probable. So why did the universe start ordered? One answer, the most widely accepted one, is inflation. A brief period of extremely rapid expansion in the first fraction of a second after the Big Bang, which would have smoothed out disorder and produced the ordered starting conditions we observe. But even inflation has to start from somewhere. And the question of why the initial conditions were arranged just right keeps getting pushed back further without being fully resolved. Boltzmann himself proposed a strange answer to a version of this question. And that answer is where the demon enters the case. Third piece of evidence, Boltzmann's own dangerous idea. In the late 1800s, Boltzmann was troubled by the question of why our universe seems to be in such an ordered state. If disorder always increases, shouldn't the universe be in maximum disorder? His answer: maybe it is, mostly. Maybe the universe as a whole is in a state of maximum entropy, total disorder, thermal equilibrium, nothing happening anywhere. Just an infinite void of uniform temperature and randomness. The natural end state of everything. But in a sufficiently large and old universe, random fluctuations happen. All the time. Atoms jiggling randomly will occasionally, very occasionally, arrange themselves into something ordered purely by chance. Most fluctuations are tiny. A brief cluster of a few atoms, here and gone in an instant. But given enough time and enough space, larger fluctuations happen too. Much larger. Including, rarely, but inevitably, fluctuations that produce entire ordered regions. Like galaxies, like solar systems, like planets, like life. Boltzmann proposed that our observable universe might be one of these rare fluctuations. A brief bubble of order in an infinite sea of disorder. And we exist inside it because only inside such a bubble could beings like us exist to ask why things are ordered. At first, this seems like a clever solution. It explains why things are ordered without requiring a special starting state. Then investigators looked more carefully and discovered something unexpected. Fourth piece of evidence: the Boltzmann Brain problem. A single planet is more likely than one that produces a solar system, and a fluctuation that produces a single brain, with all its memories fully formed, its sense of self intact, its experience of an entire lifetime assembled in an instant out of random atoms, is astronomically more likely than a fluctuation that produces an entire universe full of stars and galaxies and billions of years of history. If consciousness can arise from a sufficiently large and complex arrangement of matter, then a randomly fluctuating universe would produce conscious observers far more often by assembling them directly, as isolated brains in the void, than by building entire cosmological histories to grow them in. These spontaneously assembled conscious observers are called Boltzmann brains. And if Boltzmann's original fluctuation argument is correct, if our universe really did arise from a random fluctuation, then Boltzmann brains should vastly outnumber ordinary observers like us. Which means that in a room full of conscious beings, all of them equally likely products of a fluctuating universe, the overwhelming majority would be Boltzmann brains with false memories. Which means, statistically, you almost certainly are one. The investigation had just become very personal. Section 4. Theories. This is the point where physicists stopped treating the Boltzmann brain as a historical curiosity and started treating it as an active problem. Let's go through the serious attempts to solve it. Theory 1. The universe isn't a fluctuation, it has a real beginning. The simplest escape from the Boltzmann brain problem is to reject Boltzmann's original premise. If the universe didn't arise as a random fluctuation from an eternal state of maximum entropy, if it has a real, physical beginning, then we don't have to worry about comparing the probability of a Boltzmann brain to the probability of an entire universe. The Big Bang gave the universe a genuine starting point. The past hypothesis that the early universe had extremely low entropy isn't a cosmic accident. It's the actual starting condition of this specific universe. On this view, we don't need to explain our ordered universe as a fluctuation. It's just what happened. No comparison to Boltzmann brains required. The strength, it matches our best current cosmology. The Big Bang is real. Inflation provides a mechanism for the low entropy starting state. Ordinary observers like us are the expected result of a genuine cosmological history. The weakness, it doesn't fully escape the problem. Because even in a universe with a real beginning, if that universe runs for long enough, if it expands forever and eventually reaches maximum entropy, then in the vast stretch of time after all stars have burned out and all matter has decayed, random fluctuations will start producing Boltzmann brains again. More of them than there were ordinary observers during the universe's active lifetime. Kicking the problem into the future doesn't solve it. It just delays it. Theory 2. Cosmological constant and the fate of the universe. Modern cosmology has confirmed that the universe is expanding, and the expansion is accelerating, driven by something called dark energy. If the expansion accelerates forever, The universe will eventually reach a cold, empty state where the distance between any two particles grows so fast that random fluctuations of any significant size become essentially impossible. The space between particles grows faster than fluctuations can form. On this view, our accelerating universe might naturally suppress Boltzmann brain production. The geometry of the future universe would make large fluctuations, including conscious brains, so unlikely that they essentially never form. The strength. It uses real, confirmed physics. The accelerating expansion is not theoretical, it's measured. The weakness. Physicists have calculated that even with accelerating expansion, the math doesn't fully work out. Certain types of Boltzmann brains, very simple ones, very brief ones, might still be produced in quantities that outnumber ordinary observers. The escape isn't clean. Theory 3. The many-worlds interpretation makes the problem worse. If quantum mechanics is correct, and it appears to be, then some interpretations of quantum mechanics suggest that every possible quantum event produces a branching universe where each outcome actually occurs. In a universe with infinitely many branches, Boltzmann brains don't just outnumber ordinary observers in one universe. Most physicists working on this problem treat many worlds as an escalation rather than a solution. Theory 4. If Boltzmann brains outnumber us, our theories are wrong. This is the most pragmatic response, and it might be the most scientifically important one. The argument: if any cosmological theory, any model of the universe, predicts that Boltzmann brains vastly outnumber ordinary observers, that theory must be wrong. Not slightly wrong, fundamentally wrong. Here's why. The theory is supposed to explain our observations. But if Boltzmann brains vastly outnumber us, then a randomly selected conscious observer, according to the theory, is almost certainly a Boltzmann brain with false memories, which means there's no reason to trust that observer's observations, including the observations that led to the theory. A theory that predicts Boltzmann brains outnumber us is self-defeating. It destroys its own observational foundation. So the Boltzmann brain problem isn't just a philosophical curiosity. It's a tool for eliminating cosmological theories. Any serious cosmological model has to demonstrate that ordinary observers, beings with real histories in a real universe, outnumber Boltzmann brains by a sufficient margin. If it can't, the theory is rejected on those grounds. The strength. It turns the Boltzmann brain from a horror story into a scientific constraint, a way of weeding out bad theories. The weakness. It doesn't tell us which theory is right. It just narrows the field. And the correct theory, the one that fully solves the problem, hasn't been found. Section 5. The most likely answer. Here's what the full investigation reveals. The Boltzmann brain problem is real. It's not a crackpot idea. It's a genuine logical consequence of taking statistical physics and cosmology seriously. And it has appeared in peer-reviewed papers by physicists at Caltech, Princeton, MIT, and Stanford. But it's also, almost certainly, a sign that some piece of our current understanding is wrong. Not our observations, our interpretation of them. Here's the logic. We are ordinary observers. We have genuine memories of a genuine past. We live in a real universe with a real history. That is the evidence we are working with. If any theory predicts that observers like us should be extraordinarily rare, that the overwhelming majority of conscious beings in that theory's universe are Boltzmann brains with false memories, then that theory has a problem. Because we are here. We are evidence. And our existence should not be improbable according to our best theory of the universe. So what's most likely? The hidden truth is probably this. The universe had a genuine low-entropy beginning, not a random fluctuation. Whatever caused the Big Bang, whatever mechanism produced the initial conditions of the universe, it was not a random thermal fluctuation from a pre-existing state of maximum entropy. Something else happened. Something our current physics doesn't fully describe. Inflation almost certainly played a role in establishing the ordered early universe. But inflation itself needs a starting condition. And the deep question of why the universe began the way it did, ordered, specific, low entropy, points to physics beyond what we currently have. The Boltzmann brain problem is, at its core, a symptom of that gap. It tells us that our current picture of cosmology, good as it is incomplete, that there's a piece of the puzzle we're missing. Something about the origin of the universe, or the nature of time, or the relationship between entropy and the initial conditions of existence that we haven't figured out yet. The most reassuring evidence: modern cosmological models with inflation and accelerating expansion appear to favor ordinary observer production over Boltzmann brain production during the universe's active lifetime. We're not in obvious danger of being statistical anomalies. The unsettling evidence: in the infinite future, after all stars are dead, the math gets uncomfortable again, and nobody has found a fully clean solution. The Boltzmann brain isn't answered. It's managed. Section 6. Conclusion. Here's what stays with me after going through every piece of evidence in this case. Ludwig Boltzmann never imagined this problem. He was trying to explain why heat flows in one direction. He was trying to prove atoms were real. He was fighting for his ideas against colleagues who dismissed him. He died not knowing his ideas would be vindicated, not knowing that his work on entropy and probability would become the foundation of statistical mechanics, and not knowing that buried inside his mathematics was a monster, a thought experiment so disturbing that a century later, it would show up in cosmology papers as a genuine constraint on theories of the universe. The Boltzmann brain is what happens when you follow the laws of probability to their logical extreme. In a universe that lasts long enough, in a void that is large enough, in any system where random fluctuations happen, even tiny, rare, almost impossible fluctuations, given infinite time, every possible arrangement of matter eventually appears, including brains, including conscious experiences, including false memories of entire lifetimes. The reason this is unsettling isn't just philosophical. It's because we actually don't have a complete theory of why the universe started the way it did. We don't have a final explanation for the low-entropy initial conditions that made our existence possible. And without that explanation, we can't fully rule out that the same probability logic that creates Boltzmann brains might apply to us. The deep reason for the initial conditions. The physics of time before the Big Bang. If that phrase even means anything. That theory doesn't exist yet. Here's the detail that I genuinely cannot shake. There is no way, from the inside, for a Boltzmann brain to know that it's a Boltzmann brain. Its memories feel real. Its sense of self feels continuous. Its experience of the world feels genuine. Everything it believes about its own history is equally convincing, whether that history actually happened or was assembled from random quantum noise 5 seconds ago. It feels exactly like being you. Now, right now, you feel certain you have a real past, real memories, a real body in a real universe that has been running for 13.8 billion years. But that certainty, that feeling, is also exactly what a Boltzmann brain would feel. The physics says you almost certainly aren't one. But the physics also says we don't fully understand why. And that gap, that small, uncomfortable gap between almost certainly not and definitely not, is where the mystery lives. The universe is very old. And in a very old universe, stranger things than you have appeared from nothing.